What if I told you we've created something that's going to outlast our cities, our languages, maybe even our own species? Today, we're diving into our radioactive legacy, and it all revolves around a number so huge it completely breaks our sense of time. Okay, just look at this number, 4.5 billion years. It's a timescale so massive, it's pretty much impossible for our brains to really wrap around. So what on earth does this number actually represent? Well, this is where things get really wild. What you're looking at here is just a shocking parallel. On one side, you have the half-life of uranium-238. Now that's a naturally occurring element, but it's also the main waste product when we enrich uranium for nuclear power and weapons. And on the other side? Well, that's just the entire history of planet Earth. The time it takes for only half of this waste's radioactivity to fade is the same amount of time it took for our planet to form, for life to crawl out of the oceans, and for you and me to show up. It's mind-boggling. So you have to be asking, how is it even possible for something to last that long? It all comes down to this fundamental process in physics. It's like a clock that started ticking the second an atom was created. And, get this, there is absolutely nothing in the universe that can make it stop.
The key concept here is half-life. And, a lot of people think this is how long it takes for something to disappear completely. But that's not it at all. A half-life is the fixed, totally predictable time it takes for exactly half of a pile of radioactive atoms to change into a different element.
And this is a perfect way to picture it. So, you start with 100% of your material. After one half-life, that's 4.5 billion years for our friend U-238, you've got 50% left. Wait another half-life, and you're down to 25%. Then a third, and it's 12.5%. The pile gets smaller and smaller, but here's the part that really matters. It never, ever hits zero. The radioactivity just keeps halving on and on and on, into a future so deep, it's basically forever.
And here's the real kicker. You can't speed it up. You can't slow it down. It's a fundamental law of physics. It doesn't matter if you burn it, freeze it, crush it, or dissolve it in the strongest acid you can find. That atomic clock just keeps ticking, relentlessly. And that's what makes this waste so unbelievably persistent.
Okay, so let's pull this out of the world of abstract physics and into a very real and permanent human tragedy. We're going to Church Rock, New Mexico, back to 1979, to see what happens when this unstoppable clock collides with our world. On July 16th of that year, a dam holding uranium mill waste just broke. The result, 94 million gallons of acidic, radioactive sludge poured into the Puerco River. To this day, it's the single largest accidental release of radioactive material in U.S. history.
So, that was over 4 decades ago. You'd think a lot of that radiation would be gone by now, wouldn't you? So how much is actually left? Well, the answer is right there on your screen, 99.9%. Why so much? Because on the 4.5 billion year timeline of uranium's half-life, 40-something years is nothing. It's less than a blink of an eye. For all practical purposes, every single bit of radiation that spilled that day is still there, baked into the soil and the water of the Navajo Nation. It hasn't gone anywhere.
And this isn't just an isolated incident. This quote from the source material, man, it just puts this deep time into a chilling perspective. Waste piles, like the ones in Tuba City, Arizona, will be dangerous on an astronomical scale. We're not talking about a problem for our kids or grandkids. We're talking about a problem for a future that's almost impossible to even imagine. And this is where we have to pivot, away from the science and into the really deep ethical questions at the heart of all this. Because when you're dealing with a problem that lasts this long, you can't just think in years or centuries. You have to start thinking in terms of generations, tens of thousands of them. The framework we can use to think about this is called Intergenerational Justice. And really, it's a pretty straightforward idea. It's the concept that we, the people alive right now, have a serious moral duty to all the people who will come after us. What kind of world are we leaving them? Are the things we do today creating a burden that countless future generations will have no choice but to carry? And this quote, this just delivers the gut punch of the whole problem. It lays out the devastating imbalance of the deal we've made. The energy from all that Cold War uranium, that was used by one single generation. But the waste, that will be a lethal threat for an estimated 100,000 generations of human beings. The benefit was temporary. The consequence is practically eternal. So, here's the thing to leave you with. We often think about our ancestors, right? But we almost never stop to think that we are the ancestors of the future. But we are. We're the ancestors of a future so deep it almost defies imagination.
And our descendants, they're going to inherit everything we leave behind. So the question this radioactive clock forces us to ask is, what story will our legacy tell them about us?